All right, if you're a developer, you've almost certainly bumped into the challenge of authentication. And in today's world of complex apps, APIs, and microservices, there's one piece of tech that shows up everywhere, the JSON Web Token, or JWT. So today, we're going to pull back the curtain on these things. We'll demystify what they are, how they really work, and why getting a good handle on them is absolutely a core skill for any developer.
So let's start with a really fundamental problem, one we've all experienced. You log into an app. You click from the dashboard to your profile, to your settings. Each one of those clicks is a brand new request to the server. So how does the server know it's still you? How does it remember you're logged in without forcing you to re-enter your password on every single page? Because that would be awful, right?
Well, for a long time, the answer was something called server-side sessions. Basically, the server would remember you, store your info in its memory, and give your browser a little cookie with an ID. And with every request, the server had to look up that ID. We call that stateful, because the server has to maintain your state. But what happens when you have 100 servers? Suddenly, they all need to share a central brain to keep track of everyone. It gets messy fast. And that's exactly why the industry started shifting to a stateless approach. And that, my friends, is where JWTs come into play.
Okay, before we dive into any technical jargon, let's just build a really simple mental model. I find the best way to really get what a JWT is all about is to use a simple but really powerful analogy.
I want you to think of a JWT as a digital boarding pass. Seriously, when you log into an app, that's like checking in for your flight. The server confirms who you are, and then it hands you your boarding pass. That's the JWT. From that moment on, every time you want to access a protected part of the app, like a different API endpoint, you just show your pass. The API can look at it, see that it's legit, see who it belongs to, and know what you're allowed to do, all without having to call back to the main check-in desk every single time. It's totally self-contained.
So now for the official textbook definition. A JWT is an open standard, which just means it's a well-defined public spec that everyone agrees on, and it's for transmitting information securely. But the keywords in that definition are self-contained and digitally signed. Just like your boarding pass has your name and flight info right on it, the JWT has all the info the server needs right inside of it. The secure part comes from that digital signature, which we'll get to in a minute.
So what does this digital boarding pass actually look like? Well, if you see one, it just looks like a super long random string of letters and numbers. But it's not random at all. It actually has a very clean, very logical three-part structure.
Every single JWT you'll ever see is made of 3 distinct parts, and they're always separated by a dot. You've got the header, dot, the payload, dot, and the signature. Each of these parts is base64 encoded, which is just a way to make sure the data can be sent as plain text, and that's why it looks like gibberish. But, and this is super important, it's not encrypted. It's easily decoded.
So let's break down what each part does. The header is basically the metadata. It tells the server, hey, I'm a JWT, and here's the algorithm that was used to sign me. Then you have the payload. This is the good stuff. This is where the actual user data lives. It contains what we call claims, which are just statements about the user, like their ID, their role, maybe their permissions. And finally, the signature. This is the security guard. It's a cryptographic proof that the header and payload haven't been messed with, and that it was actually your server that created it in the first place.
Now, let's zoom in on that payload for a second. The claims inside it are usually split into 2 types. First, you've got registered claims. Think of these as the standard recommended fields, like IS for who issued the token, sub for the subject, which is usually the user's ID, and exp for the expiration time. Then you've got custom claims, and this is where you can put your own application-specific data. Things like a user's role or a list of their permissions. That's all custom.
Okay, stop what you're doing and listen to this. This is, without a doubt, the single most important thing you need to understand about JWTs. The payload is base64 encoded. It is not encrypted. I'm going to say that again. It is not encrypted. Anyone who gets their hands on a JWT can pop it into a decoder, like the one on jwt.io, and read everything in the payload plain as day. This is a feature, not a bug, but it means you must never, ever put sensitive data like passwords, social security numbers, or anything you wouldn't want public inside a JWT payload. All right, so we've taken the token apart, we've looked at all the pieces. Now let's put it all together and see how this whole system works in a real application. Let's walk through the authentication dance.
It's a pretty elegant 6-step process. Step 1, user logs in. Easy enough. Step 2, server checks if the password is correct. Step 3,
Now here's the magic moment. The server creates a brand new JWT, signs it with a secret key that only it knows, and sends that token back to the user's browser. Step 4. The browser just has to store this token somewhere safe. Step 5. From now on, for every single request to the server, the browser attaches that JWT in a special header called authorization. And finally, Step 6. The server gets the request, looks at the token, quickly verifies the signature is legit, and grants access. And notice what didn't happen. No database lookup to figure out who you are. The token told it everything it needed to know.
Now, we talked about this before, but it is so incredibly important that we need to dedicate a whole section to it. Let's really hammer home the security model of a JWT, because it's different from what you might expect.
Let's be crystal clear about what that signature at the end of the token does and does not do. Its purpose is not confidentiality. It does not hide the data. Its real job is to guarantee two other things: integrity and authenticity. Integrity means the data has not been tampered with. It's like a tamper-proof seal. Authenticity means you can be 100% sure that the token was created by the server that holds the secret key and not by some bad guy.
Because of this security model, you have to follow some best practices. These are not optional. First, we've said it a dozen times, never store sensitive data in the payload. Second, always use HTTPS to protect the token from being stolen in transit. Third, keep your access tokens short-lived, like 15 minutes. For longer sessions, you use a separate refresh token to get a new access token without the user having to log in again. And most importantly, guard your signing keys with your life. If an attacker steals your secret key, they can forge valid tokens for any user. It is game over.
Look, JWTs are an incredibly powerful tool to have in your developer toolkit, but they are not a silver bullet. It is so important to understand the trade-offs so you can make the right architectural decision for your app. So let's wrap up with the key takeaways.
This chart really tells the whole story. With JWTs, you get to be stateless, which is a massive win for scaling and microservices. The token has all the info it needs. But, and this is the big but, revocation is hard. If a token gets stolen, it's valid until it expires. With old-school sessions, you could just log a user out immediately by deleting their session on the server. So you can see why JWTs are perfect for APIs and mobile apps, but sessions can still be a good choice for simpler apps where that instant logout is a critical feature.
So I'm going to leave you with one last question to chew on. We say that JWTs make our servers stateless, which is awesome. It simplifies things on the back end. But that complexity, it doesn't just disappear into thin air. It moves. Now the client is responsible for managing tokens. We have to worry about refresh token logic, secure storage on the browser. That complexity has been shifted. There's no free lunch in software architecture. Understanding that trade-off is what separates good developers from great ones.